All right, so our next step is to add bonds and electrons. So there's kind of two steps to this, one step or two sub-steps. So first we're going to start with one bond, which remember is 2 electrons from each terminal atom. So the ones on the end to one more central atom. Oftentimes it's the most central, but not always. And then after that, what we want to do is we want to give atoms octets by giving them lone pairs. And we want to start with the more electronegative terminal atoms. And then while we're doing this, we want to keep track of the electrons we've used and how many are remaining. So we're talking about here is the valence electrons. Let's go ahead and go through step 1 and start adding bonds to things. So I've copied this down from our previous slide, and then I've added the valence electrons that we previously calculated as well. So first thing I'm going to do is just draw a bond between each terminal atom to a more central atom. So there's one there and then one there. And then remember, each bond is 2 electrons. So that would subtract out 4 from here, leaving us behind with 12. In this NH4 example, we would draw one bond from each hydrogen to each nitrogen. Each bond is 2 electrons. There's 4 of them. That uses up all 8 of our valence electrons. Over here, we want to draw a bond from each carbon to each hydrogen, and then one from the carbon to the oxygen, and then one from the oxygen to the hydrogen. If we think about there, that's 10 electrons, which means that we have 4 remaining. And then over here, one bond from each oxygen to the nitrogen in the center. That's 3 bonds or 6 electrons. So we've got 18 remaining, right? So we're done with step A. Now we want to go ahead and move on to step B. We want to give atoms octets by giving them lone pairs, and we want to start with the more electronegative or the more terminal atoms first, while keeping track of everything, right? So in this case, we've got 12 electrons. So let's go ahead and give this oxygen, this more terminal atom, an octet. It's already got 2 from the bond, so it needs 6 more. So there's the 6 there, and then same thing for that other one on the other side. And so if you think about that, that's used up all 6 of our remaining electrons. Then H4 plus, there's no more valence electrons left, so we're good there. If we think about this CH3OH, remember hydrogen only wants a duet, so all those hydrogens are happy. The oxygen is still short of an octet. It needs 4 more, and that's exactly how many electrons we have left. So we just go ahead and do that. If we think about this one, each oxygen already has 2 electrons, which means it wants 6 more. So they each get 3 lone pairs. And if you think about that, that's all 18 of our valence electrons. So all those electrons are used up, right? And in this step, by the conclusion of this step, you should indeed use up all of your electrons. But we are not done yet with our Lewis structures.